Have you ever wished you could build an ESP32 device that could control higher voltage devices, even AC devices like lamps, fans, or small appliances? In this video, I'll cover the use of relays with the ESP32. We'll look at what relays are, how they work, and how to safely select the right one for your project. I'll cover pinouts and wiring diagrams and show how easy it is to add a relay to both your Arduino and ESPHome projects. Hi, and welcome to Resin Chem Tech. Today I'm going to cover the use of relays with the ESP32. Relays are powerful components that can allow your low voltage ESP to control high voltage circuits, even AC circuits for things like lights and fans. In order to ensure power is cut off to these external components while your ESP32 continues to run. Yet relays are actually one of the easiest components to use, requiring only one GPIO pin and very simple coding in Arduino, ESPHome, or even other languages like Python. There are a few simple safety rules to follow, but I'll cover those shortly. There are many smart home devices that use relays. Smart switches, dimmers, and things like plugs all have one or more relays inside. There are even relays that you can add to an existing switch, like these ones by Shelly. But today I'm going to cover how to add a relay to your own DIY project. As usual, be sure to check the video description below for links to all the parts that I use, along with a companion written guide that will have copies of all the wiring diagrams and code samples that I use. First, let's cover relays in general, including how to select the proper one for your project. Now, if you're already familiar with the types of relays, specifications, and concepts like wet and dry contacts, feel free to use the timeline down below to go ahead and skip over this part. A relay, at its most basic, is nothing more than an electronically controlled switch. When the relay receives a signal, it flips a switch on the load side and power flows. When that control signal flips again, then the switch is also flipped and power is stopped on the load side. But not all relays are created equal. One very important property of relays is whether it is using wet or dry contacts. With wet contacts, the same power source is used for the control circuitry as used for the switched power load. But the control and load circuits are not isolated. This means if your load is using something like 120 volts AC, that same voltage could be sent back to your controlling device. In this case, something like an ESP32. And if you feed 120 volts to a GPIO pin on an ESP, well, that's not going to go very well. So unless your load is also operating at 5 volts, you will most likely want a relay with dry contacts. With dry contacts, the control circuit and the switched load use two separate power supplies. The two circuits are electrically isolated. This means we can use something like a 5-volt DC circuit to control a 120-volt AC circuit, and your ESP will be much happier. So in summary, wet contact relays are used with a single power source, and both the control circuit and load must use compatible voltages. The wiring is a bit simpler due to the single power supply. Specifications for this type of relay may explicitly state wet contacts, but if it doesn't list something about dry contacts or isolated circuits, you should assume it is using wet contacts. Dry contacts, on the other hand, use separately isolated circuits for the control and the load. This means the load can have different voltage than the control circuit, but they can also be the same as well. A little more wiring is necessary since each side of the relay requires its own power connection. These components explicitly list dry contacts, but may also specify the two circuits are optically isolated using optocoupler isolation. With an optocoupler, instead of using something like a coil, the control side has an LED and the load side has a photoresistor. This means that there's no physical electrical connection between the two sides. The only link is the light beam. This is actually the most common type of relay you're likely to use with your DIY projects, and is the type we'll use for the rest of this video. But before we select the relay and wire it up to the ESP32, we need to carefully consider voltage and current for both sides of the dry contact or optically isolated relay. Now, most relays will list two sets of specifications. One is the maximum voltage and current for the load or the output side of the relay. In this case, both of these relays can support up to 10 amps at 250 volts AC or 10 amps at 30 volts DC. The other rating is the voltage requirements for the control side. In this case, the top relay is powered and controlled by 3 volts, while the bottom one is a 5-volt relay. But what about the current draw on the control side? Depending on the type of relay, energizing the relay, especially if some sort of coil is involved, may draw too much power for the ESP's 5-volt or 3.3-volt pin. But let's go ahead and throw a couple of relays on a breadboard with an ESP32 and we'll measure the current draw on the control side. I'll be using a standard ESP32 for all my examples, but the same process would apply whether you're using an ESP8266, Arduino board, or even a Raspberry Pi. There will be some minor wiring differences based on the voltage of the GPIO pins, as most Arduino boards have 5-volt GPIO pins, while the ESP32 and Raspberry Pi have 3.3-volt pins, but the wiring coding are very similar regardless of the microcontroller or SBC used. I'm also going to take a look at both a 3-volt and a 5-volt relay. They operate in a similar manner, but the 3-volt relay needs 3 volts for power and expects a 3-volt signal, while the 5-volt relay will obviously need 5 volts, but it also expects a 5-volt for the data signal, meaning we'll potentially need to deal with both 3.3 volts and 5 volts. So a few other components such as a buck converter or maybe a logic level shifter may be needed. But before we consider connecting a relay to either the 3.3 volt or the 5 volt power pins of the ESP32 for powering the relays, I need to determine how much current is drawn by the relay when it's energized. This could impact how I end up powering the relay. Now ignore all the spaghetti wiring for a second. I'll cover the pinouts and wiring for the relays in just a minute. Just know that for this simple test, I've got 2 buttons that send a signal to either the 5 volt or the 3.3 volt relay to toggle the relay state. And I'll be using a multimeter to measure the current draw. Also note that I don't have anything connected to the output side of either relay, but since these relays have isolation between the 2 circuits, nothing connected to the output side is going to impact the current draw on the input or the control side. And since I don't know how much current is actually going to be drawn, I don't have anything connected to the power pins of the ESP32 at this point. I'm either connecting the 5 volts or 3.3 volts from the power source directly to the relay. Right now, both relays are off. The 5-volt relay is actually showing a very small current draw of just over 1 milliamp, but the 3.3 volt is showing nothing. So now I'm going to go ahead and toggle these relays on, and you'll be able to see that the relay is on by the little LED that comes on, but we can see that this one is pulling around 73 milliamps just to keep that relay energized. So now let's try the 3.3 volt relay. We can see that's actually pulling significantly more. It's pulling about 118 milliamps to keep this relay energized. So I need to keep this in mind when I determine how to wire up the relay. Now in this case, I could probably use the 5 volt or the 3.3 volt pin without any major issues, but if I'm connecting additional peripherals to one of these power pins, I could end up exceeding the milliamp rating for the power pins. I'll show both ways to wire this using the pins and directly from the power supply when we get to the wiring. If you don't have the ability to measure the current, you can always try to find a specification sheet for the particular relay you're using. But as I've shown in previous videos, different manufacturers may use slightly different components, so it's always better to measure the actual current yourself if possible, and this way you're assured of any current needs to properly power the relay. But now let's take a little closer look at the relays themselves, including the terminals on both ends and any jumpers that might be available. Let's start with the input or control side terminals. Both the 3 volt and 5 volt relays have the same terminals on the input side, although they are in a different order and labeled slightly differently. Both have terminals for the relay's positive power, VCC or DC plus, and ground or DC negative. And yes, 3.3 volts is okay for the 3 volt relay and is within specifications. The third terminal on both relays, labeled in, is for the control data signal. Again, a logical 3 volt signal is expected for the 3 volt relay and a 5 volt logic signal for the 5 volt relay. And you might be asking, could you control the 5 volt relay with a 3.3 volt signal? Now, this is very similar to controlling 5 volt or 12 volt LED strips that also expect a logical 5 volt data signal. And the short answer is maybe. If the wiring is kept short to minimize voltage drop, some 5 volt relays may trigger from a 3.3 volt signal. Others may not, or you may experience inconsistent results. For the most reliable operation, the data signal logical voltage should match the voltage to power the relay. Now I'll come back to the signal voltage in a minute, but first let's take a look at the output or switched side terminals. On the opposite end, you'll find the 3 terminals for connecting your switched outlet. In this case, both the 3 volt and the 5 volt have the same terminals. NC for normally closed, COM for common, and NO for normally open. In fact, the relay is a single-pole double-throw switch. By default, when the relay is off, the NC and common terminals are connected, and when the relay is on or energized, the NO and common terminals are connected. In fact, even though nothing, not even power, is connected to this relay, we can see that the normally closed and common terminals are already connected. And this does bring up an important safety point, especially with dealing with higher voltages on the switch side. Use a little bit of caution when connecting higher power devices to the normally closed terminal, as the circuit will be completed as soon as the external device is connected. Having both the normally open and normally closed terminals, let us decide whether we want the switch circuit to be on when the relay is on via the normally open terminal, or whether we want our switch circuit to be on when the relay is off via the normally closed terminal. In addition, having both a normally closed and normally open terminal gives us a unique ability to actually switch between two circuits. And I'll show an example of this a bit later when we get to wiring up the relay to the ESP32. But first note that these relays also have some jumpers on board, and these jumpers can change how the relay operates or how it's wired. For this particular 3-volt relay, there are two jumpers. These jumpers simply connect the VCC and ground terminals to the relay's power. In most cases, you just leave both jumpers installed and power the relay via the screw terminals. But if you have a special need or use case, you can remove the jumpers and power your relay directly via the pins. 5-volt relay has a single 3-pin jumper. It might be a bit hard to see, but one side of this jumper is labeled with an L and the other side is labeled with an H. But the text right next to this reads high-low trigger level. This means we can set the jumper to control whether the relay is to be turned on or energized with a low or a high logical data signal. When set as it is here to high, then a high signal would turn the relay on and a low signal would turn it off. When the jumper is moved to set to low as it is here, then the opposite would be true. A low signal would turn the relay on and a high signal turns it off. If you find that your relay is operating opposite of what you expect or desire, see if there's a jumper similar to this and just flip its position. Now, not every relay will have this jumper option. Other relays may have different jumpers as well. Check the documentation for your particular relay if it makes jumpers available. Okay, that's probably more than you ever wanted to know about relays, but with this knowledge, let's go ahead and hook up a relay to an ESP32 and try controlling an external circuit. I'm going to cover a couple different wiring methods for both the 3-volt and the 5-volt relay. To begin, the method I'm showing here is probably the simplest of all the variations I'm going to show. I'm powering the ESP32 via the USB port, which is 5 volts DC. I'm using a 3-volt relay, and I'm powering the relay off the 3.3 volt and ground pins of the ESP32. The only other wiring here is the data signal from GPIO 27 in this case to the N terminal of the relay. Now I have added a push button here just as a simple way to toggle the relay off and on, but this could also be a motion detector, presence detector, or some other type of sensor. And of course, once we integrate this project into Home Assistant, we'll have a switch entity that can also be used to toggle the relay. More on Home Assistant in a bit. On the output or switch side of the relay, I have a 120 volt AC circuit. And for this example, I'm just going to control a simple light. The hot or line in is connected to the common terminal of the relay, and then the line out is connected to the normally open terminal and goes directly to the light. The neutrals are simply connected together. Now, using the normally open terminal means that the relay and the light ought to be in sync. When the relay is off, the light will be off. When the relay is turned on, the light will come on. So in this case, I'm using a 3-volt DC circuit on this side to control a 120 volt AC circuit on the other side. Currently, the relay is off, as is the light. When I press the button, it's going to send a signal to turn on the relay, which you can tell by the LED here. That energizes the relay and makes the circuit complete over here for the 120 volt side and powers our light on. And of course, the converse of that, if I send a signal to turn the relay off, again, it's going to break the circuit and kill the power over here on the 120 volt side. Now, while this is the easiest way to wire the relay, it isn't necessarily the best. Recall that this relay can draw up to 120 milliamps when energized, and the 3.3 volt pin over here has a limit on the current, and this has to be shared with the ESP32 chip itself. If you wanted to connect additional peripherals, that limit could easily be exceeded. So let's take a look at an alternate way to actually power the relay. To power the relay separately, I'm using a 5 volt power supply instead of the USB port. Went ahead and brought the 5 volts in, and I've created a 5-volt power rail here along the top, and I'm powering the ESP32 off the VIN or the VIN and the ground pins from this 5-volt rail. We obviously can't use the 5-volt rail to power the 3-volt relay. Instead, I'm going to take the incoming 5 volts and I'm going to use something called a step-down buck converter. And this particular buck converter can take input of anywhere from 4.5 to 16 volts in and can produce a stable 3.3 volts out. So I'm taking 5 volts in, stepping that down to 3 volts, creating a 3-volt power rail here that is powering my relay. So I'm powering the relay off of this instead of the 3.3 volt and ground pins of the ESP32. And since this buck converter can handle up to 2 amps of current, the relay won't cause any issues at all with drawing too much power. The rest of the wiring, including the signal and the AC side, are identical and it works in the same manner. Once again, when I send a signal to the relay, it turns on and powers the light. And when I send the signal to turn the relay off, it turns off the light. So it works just like before, except we're no longer pulling the current for the relay through the ESP32, and we're feeding that directly from the power supply via a step-down buck converter. Before you ask, yes, it would be possible to use 2 separate power supplies, 5 volts for the ESP32 and 3 volts for the relay. But 2 important points if you opt for this method. First, you must create a common ground between the 2 power supplies. But more importantly, ensure that the positive 3 volts and 5 volts never connect together anywhere in your circuit. But theoretically, you can use 2 different power supplies for the 3-volt relay. But let's move on now and take a look at the 5-volt relay. The 5-volt relay setup is very similar to the 3-volt version. While the ESP32 is again being powered by a 5-volt USB, the relay in this case is being powered off the 5-volt or the VIN and ground pins of the ESP32 instead of the 3.3-volt pin. But you'll notice a new component has been added. This is a simple logic level shifter and is used to shift the 3.3 volts from the GPIO pin up to the logical 5 volts expected by the relay. Now I've covered use of this logic level shifter in a lot of my LED related videos, and why I no longer recommend it for LEDs, it's perfectly fine for something like shifting the data control line for a relay. The data signal from GPIO 26 this time is passing into the LV side of the shifter and is shifted up to logical 5 volts before going into the N terminal of the relay. The output or AC circuit side is the same, except just to show the difference, I'm going to use the common and normally closed terminals here instead of the normally open terminal. This means the AC circuit will now operate opposite to the state of the relay. Let me go ahead and turn on the power to the AC side circuit here, and you'll notice that the circuit is on even though the relay is off. If I go ahead and toggle the relay on, now notice that the AC side is off, and then vice versa. This really just shows the difference between using the normally open versus the normally closed terminals. But just like the first 3-volt wiring, we are still pulling all the current for the relay through the VIN or the 5-volt pin of the ESP32. However, we can make a simple change to power the relay directly off the 5-volt power supply. Instead of using the USB port of the ESP32, I'm once again using a standalone power supply, and just like with the 3-volt relay, I'm creating a 5-volt power rail directly off the power source. This 5-volt rail is powering the ESP32 off of its 5-volt and ground pins, but it's also powering the relay directly. And since I'm still using the normally closed terminal for the AC circuit, the relay is still operating opposite of the state of the AC circuit. When it's on, the relay's off. When the relay's on, this circuit is off. By the way, if you've done any projects with 5-volt LED strips, this is the same wiring technique used to power the LEDs in parallel instead of through the ESP32's power pins. Before I get to the firmware and Home Assistant integration, I did mention earlier that having both the normally open and normally closed terminals provides a unique opportunity to switch between 2 different circuits on the output side of the relay. As an example, I have the same exact 5-volt relay setup as before, but now I've added a second 120-volt powered light bulb. Again, the incoming or the hot line is connected to my common terminal. The light bulb here on top is connected to my normally closed terminal, and the light bulb here on the bottom is connected to the normally open terminal. All neutral wires are all bundled together. Let me go ahead and turn on the power on the AC side. As expected, since the relay is currently off, the normally closed circuit is on just like it was before. But when I toggle the relay, the normally closed side gets turned off while the normally open side gets turned on. I can now use the relay and the relay state to easily toggle between which circuit is active on the output side of the relay. The only caveat here is both circuits on the output side must operate at the same voltage since they are sharing a common incoming power line. And while I've been showing AC circuits here, you certainly aren't limited to that. In fact, you can even use the relay to switch between different data signals. And that's exactly what I did in my video where I built a matrix clock, but it also has full WLED capabilities available. In this case, a relay is used to take the data signal from one of two different controllers, one with custom Arduino code for the clock features and one with WLED. By switching the state of the relay, it changes which controller signal is sent to the LEDs. I just showed this to demonstrate that relays aren't necessarily restricted to switching only powered circuits. Of course, to make all this work, we need firmware on the ESP32. Now, implementing a relay is extremely easy, and I'll show how to do it in both Arduino and ESPHome, although this process could easily be adapted for other languages like Python. Let's start with Arduino. Since all we need to do to control the relay is set a GPIO pin high or low, we don't need any external libraries for the relay. Now, first, I like to define a constant at the top that specifies the GPIO pin connected to the relay's in terminal. In this case, it's GPIO 26. Then in the setup routine, I define this pin as an output pin. With that simple setup, now anytime I want to switch the state of the relay, I just set the GPIO pin to high or low. Now, I do like to also set the state of the relay at boot time, so I add a statement to the setup to assure the relay is initially off. Now recall that my 5-volt relay had a jumper that specified that the relay is triggered or turned on by a high or low signal. If it is set to the low position, then I simply need to swap the high and the low in the code. But that's all there is to using a relay in Arduino. In fact, that's the code I used for all the examples I just showed. Now I did add a button connected to a GPIO pin as an input. Then in the main loop, I simply read the current state of the button and the relay. If the button is pressed, then I simply toggle the state of the relay. Easy, right? But what about Home Assistant integration and using the relay in automations? Well, there are numerous ways to integrate your own Arduino project into Home Assistant, but one of the most common ways is to add MQTT to your project. MQTT is a lightweight communication protocol supported by Home Assistant, Arduino, and many other languages that easily allow the exchange of data wirelessly. Now, I don't have time in this video to go into the details of setting up and using MQTT, but I have a number of other videos that cover the basics of MQTT, creating MQTT entities in Home Assistant, and how to even add MQTT and Discovery to your own Arduino projects. But the net effect, once you've added MQTT, you should have a simple switch entity in Home Assistant that could be used on a dashboard or in automations to control your relay. But of course, if using ESPHome, it automatically integrates directly into Home Assistant. So let's take a look at how to do that next. When you create a new ESPHome node, you select the type of board you're using, and it creates the initial framework with things like connecting to your Wi-Fi, setting up the Home Assistant API integration, a captive portal, etc. I won't cover that here, but once you have the starting framework, you add any custom components for your project. In this case, we just need to add a simple GPIO switch and specify the GPIO pin used for the data control line. That's it. When you install this on your ESP32 or other board, it will automatically be discovered in Home Assistant. And once you integrate it, a new switch entity, just like the Arduino version, will be created and you can use it on a dashboard or in your automations and scripts. In fact, I have the ESPHome version connected to my sample circuit. Now I can flip the dashboard switch to toggle the relay and the connected circuit. This is all being done wirelessly, but locally on my network, so it's really fast and without any internet or cloud services. Now, of course, once you create your code, you need to flash it to your ESP32 or whatever board you're using. If you haven't done this before, I do have another video that covers how to flash firmware to the ESP8266 or ESP32 if you want to take a peek at that. Of course, whether you're using Arduino, ESPHome, or another programming language, there are a lot of additional options and settings that could be applied to your switch definition. You can do things like invert the switch or apply certain power on states. There are a lot of other options, and you can check out the documentation for details on those. But hopefully this video has given you enough information to get started using relays in your own DIY projects. I'll be back soon with more videos on DIY electronics, LEDs, and Home Assistant. But until that time, I'd like to say thank you for watching, and I hope to see you again soon.